So in the previous video, we have seen an overview of linked list with tail. In this video, we will implement the same. So what I'll do is I'll just copy paste the code of a linked list and I'll remove the unnecessary part from here. So I'll keep isempty get size. I'll remove the prepend. We will implement it separately. Print will not change. So I'll keep the print. I'll remove the remaining things. So as you have seen earlier, we need a tail pointer. So we will just initialize it to null initially. So we will have this dot tail is equal to null. There is no other changes in this function. So the first function we will write is a prepend. This will receive a value and I'll create the node, new node of value. If the list is empty, then we will just point both head and tail to this node. So that will be this dot head is equal to node and this dot tail is equal to node. If that is not the case, we just need to point the node dot next is equal to head and make the node as the new head. That is node dot next is equal to this dot head and this dot head is equal to node. And we shouldn't forget to increment the size of the linked list. So if you compare it with the earlier function, this line is the only difference we are doing here. Whenever the linked list is empty and we are prepending a new node, we are pointing this tail to the newly inserted node. So that's the prepend method. Next we will do the append one. I'll copy this section of the code from here because this doesn't change. Else case will be, so we have to point tail dot next to the new node and we will have to point the tail to the newly created node. So that is this dot tail dot next is equal to node and this dot tail is equal to node. Next we will write the delete from head method. So I'll declare remove node as this dot head since we are removing from the head. Then I'll check if the size is 0, that means there are nothing in the list, then I'll just return null, we don't have anything to delete. And next scenario is when there is only one node in the list and that is the node to be deleted, then we need to point both head and tail to null. So else if this dot get size is equal to 1, then we just do this dot head is equal to null and this dot tail is equal to null. And the last scenario is when there is more than one node in the list. So in that case, what we do is we point the head to the next node. That is this dot head is equal to this dot head dot next. And finally, we return the removed nodes value. As a last method, I'll write delete from tail. This will follow the similar structure for size equal to 0 and 1. In the else case, as we have seen, we need to traverse the entire list to delete the last node because we need to get the reference to the previous node so that we can assign the tail to the previous node. So I'll write let previous equal to this dot head. I'll traverse until tail, that is until previous dot next is not equal to tail. Previous is equal to previous dot next. So after this while loop, we will reach the node which is previous to the tail. So what I'll do is I'll point previous dot next is equal to null. Previous dot next is equal to null. And I need to update the tail. So tail will be previous. That is this dot tail is equal to previous. And finally, reduce the size. This dot size minus minus and return removed node dot value. We forgot to decrement the size here. We have to do that here as well. So I'll just copy paste it here. So that's it about the implementation. Let us test it. So I'll append a couple of items, linked list dot append of 10, 20, and I'll print it. So we have a bug here. We have to increment this size. So as you can see, it is working fine now. I'll test the prepend method as well. So linked list dot prepend of 5, and I'll just print it. As you can see, prepend is also working fine. So now let us test both the delete methods. Delete method will not print anything, so I need to log whatever is returned from them. So linked list dot delete from head. So head is 5. So let us see. So 5 is printed. Now let us print the linked list and see if it is deleted actually. Yes, as you can see, it is deleted. And let us delete from the tail as well and print it and see. So now as you can see, item is deleted from the tail, but the return value is not the deleted value. That is because we did a mistake while copy pasting here. While you are deleting from tail, you have to, the remove node is tail, not head. So we have to return the correct one. So as you can see, it is working fine now. So that is how linked list with the tail works. I know I've made a lot of bugs while coding. Hope you have captured it while coding itself. In the next couple of videos, let us see some interesting concept how we can use linked list as stack and queue. Hope you're liking this series. If you are, please consider subscribing to the channel. See you in the next one.